Hello all. Welcome to SVS213. Visualize and design your architecture using AWS Application Composer. As a solutions architect, my day job is to work with customers like you. And one key question which always comes in with any customer conversation, even when I was talking to customers here, is that you all have amazing understanding of your requirements and your end customers' requirements. And question you ask is that, Naren, I have this idea of a web application, mobile application, or I have a solution idea. How do I take that idea, quickly build a solution, and deliver it to the end customer's doorstep as quickly and as efficiently as possible, thus delivering the customer value and customer satisfaction, and hence the business growth. And in this talk today, I'm going to show you how you can take that concept to a customer as quickly as possible. My name is Naren Gaka. You can call me Naren. Let's get started. AWS Application Composer is a tool with which you can visually compose, configure, and connect serverless resources. And by doing so, it will give you infrastructure as a code which is deployment ready and follows AWS best practices. We will now take an idea of a customer requirement. For example, document summary app. Over the course of next 15 minutes, let's adopt this as our requirement, saying that you have tons of documents. It could be several hundred lines or maybe hundreds of pages. Let's build an application which leverages Amazon Bedrock or an AI model to summarize that document and save that in a persistent database so that we can also access it using either a mobile application or a web application using an API call. So if we switch back to our demo, let's actually see things in action and take this idea into reality. Okay, this is my AWS console. I'm going to access Application Composer. Okay, either you can create a demo project or create a new project. So I'm going to create a new project. Okay, this is the Application Composer console page, wherein on the left side or right side of you guys, I think, you can see resources. There are two kinds of resource cards. One is enhanced component, and other thing is a standard IOC resource. So enhanced component could be a combination of one or multiple CloudFormation resources, and that's why it's called a component. And whereas an standard ISC resource is a CloudFormation resource itself. And on the right side here, we have a visual canvas where we can drag and drop these resource cards and connect them together. And while doing that, it's going to give us a template which we can save into our local file system. If needed, we can check into our CI/CD, GitHub repositories, and let pipeline do the rest for us, right? So what I'm doing is that I want whatever I'm doing on the Amazon AWS console here to save in our local file system so that I can check into my version control system or deploy it, right? So I'm going to go to menu. I'm going to activate local sync. So what it is asking is, it is asking session-based limited permissions for this browser window to access my folder so that it can save the files in there. Okay, I'm going to create a new folder called document summary. Select, and I'm giving it view permissions. And also it's asking, okay, are you okay for me to save files, right? So I'm going to save files there. Perfect. Now autosave is enabled. So whatever we are doing it's going to save it in my local file system as well. Okay, if we go back to our design, which we have referred to, you see there could be two flows. As you can imagine, the serverless architectures can be either asynchronous, wherein you submit a job and let it do the rest in the background, and synchronous call for our API call, wherein you are accessing through a mobile or a web application, you want the results instantaneously. That is the synchronous flow. Let's create both of those flows in our application. For our asynchronous flow, let's start with an S3 simple storage service S3 bucket. So I'm going to drag and drop in my canvas this S3 bucket. If I click on details, we can name it Documents Summary S3. And if you notice, by default, it is blocking the public access to this S3 bucket. And also, if I go to the template, we see that it is following the best practices of saving or encrypting the data at rest. And if you scroll down, and also implemented a policy wherein it is denying the traffic in transit, which is not encrypted as well, right? So it's following the best practices there. Okay. We want to save, once a user uploads an object or our documents in our S3 bucket, we want them to be analyzed by some compute, for which let's leverage Amazon Lambda. Okay, I'm going to drag and drop the Lambda function. Let's call it process files Lambda. Okay. Now here you see that each resource card has properties. It may not be fully exhaustive list of all the supported properties, but it gives you defaults for minimum properties so that you can get started. And if you want additional properties, you can always go to the template and change them. Okay, for my package type, I'm going to leave the zip and let me call the source path as process Lambda. For my runtime, let me select Python. Okay, you can select the other properties like architecture. You can change the memory, timeout for the Lambda function, enable provisioned or reserve concurrency, etc. Let's click Save on this one. Okay, now you may wonder that each resource card has two dots or two ports, or what we call, one on the left side and one on the right side, right? So one on the left indicates what event can trigger or access this S3 bucket, and one on the right indicates what this particular S3 bucket can trigger as a next action in a workflow. Now, let's create a connection between our S3 bucket and the Lambda function. Now, as soon as I click here, now you see, with the little guesswork, it is telling you that this is a supported method of integration. So as soon as I connect both of them, what it has done is, it has added a code saying that for every event of object creation or removal, it's going to trigger that Lambda function, right? So which we are okay with, because we want this Lambda function to be executed when a file or a document is uploaded on our S3 bucket. Okay, for our persistent database, let's leverage Amazon DynamoDB. Let me drag and drop the DynamoDB table in my canvas. Let's call it Summary DB. You can set the partition key, which default I'm okay with. You can also set sort key or expiration, etc. Let's click Save. Now again, we can connect both the ports. Now again, as with anything, what it has done is, it has automatically added the variables for the Lambda function, saying that both the Lambda function, both the table name and the ARN of that resource, so that we can refer in our business logic, which goes inside the Lambda function. And also, it has created a DynamoDB create read CRUD policy, create read update and delete policy, so that when Lambda function executes, it has permissions to access those DynamoDB tables which we have created. Perfect. And for our synchronous flow, let's leverage Amazon API Gateway. I'm going to drag and drop API here. Let's call it Summary API. Now again, you can set various authorizer or routes, like get a summary or a get summary by ID, etc. And set, if you want to refer an external API documentation, etc., you can do so. Okay, let's save that. Similarly, let's again get a Lambda function to process our API requests. I'm going to call it get summary API. Okay, now if you notice here, it's because we have selected our runtime in for a previous Lambda, it automatically remembers that it's also applying the same thing for our new Lambda function, which is good. Okay, let's connect all these resources. Perfect. So we have both synchronous and asynchronous flows created. But one thing we haven't done so far is that our process Lambda API or process Lambda function needs access to Bedrock as well. So let's go ahead and create permissions for that. For that, I'm going to use standard ISE resource to create an additional policy and assign it to our process Lambda function. So I'm going to drag and drop the managed policy here. Unlike our components, enhanced components, for the standard ISE resource, we have to give it the configuration as a JSON format, right? So let's call this as Bedrock access, and let's get our resource configuration, which I have done it here. Perfect. And let's also refer in our Lambda function so that it knows or it is assigned. Okay. Perfect. So our design is done. So is our infrastructure as a template, which is already created and synced in our local file system. Let's go ahead and deploy this architecture. Okay, so this is my IDE. Let me open up the new folder which we have created. We called it, document summary. Okay, so as you see, we have the template, our Lambda functions, etc. already there in our system. Okay, to deploy this, what I'm going to do is I'm going to use AWS SAM, serverless application model, which is a combination of a CLI and a shorthand notation for defining serverless resources to deploy this template which we have. So I'm using SAM accelerate command called SAM sync. I'm giving it a stack name or a CloudFormation stack name. We're calling it summary app demo. Let's select a region. Perfect. Let's go ahead and see what it does. So as soon as I hit enter, what it's doing is it's validating the template for any syntax issues or anything. It's compiling our Lambda functions. It's also creating those artifacts and deploying via CloudFormation stacks. So while it is deploying it, what I have done is I've already pre-created a stack with the exact same configuration. And let's see, let's use that to test our architecture. Okay, so we have this app, and alongside the infrastructure as a code template here, what I've done is I've leveraged Amazon Code Whisperer to create, or maybe rather, let's call it generate the business logic for us so that we can test the end-to-end flow. For example, all my get summary Lambda is doing is it is fetching all the objects or the summary of the documents from the DynamoDB table and giving it to the API as a response. And for our process Lambda, what it's doing is it is basically leveraging Bedrock AI model and summarizing the documents in under 100 words and saving it in our DynamoDB table. Perfect. So I have some sample files of AWS services. For example, EC2, where it has like almost maybe 600-700 lines of text or document. Let's go ahead and upload this in the S3 bucket, and let's see what exactly does it do in a summary, right? So I'm going to use AWS CLI command to sync or upload these documents. Okay, so the document upload is complete. Let's go to our AWS console and go to DynamoDB. So we're using it in Oregon region tables. This is our summary app table. Okay, now if I explore the table items, now you see that the processing already completed for all those documents which we have uploaded. So obviously the time is set as UTC, which is in sync with my laptop time zone. And let's check one of the results. Let's see what it has done to our EC2, let's say. Okay, so it's saving it as a timestamp. It is reflecting to the object or the document name. And it's also giving the summary which we are after. Okay, so it basically says that EC2 offers a wide variety of instance types, optimized for various different purposes, etc. And for our API, for our synchronous flow, so we can either test it from here. We can simply test where it has retrieved all the, visually it's not appealing, but for that, let me trigger it in our response. Yeah, now you see that with the API GET response, it is able to fetch all the results from our backend database for all the documents which we have uploaded. Okay, so quickly let me show you one more thing. By no means this is a full requirement for a business application, right? You can simply keep extending this architecture, keep adding more and more features. Like you can leverage AWS step functions, for example, and you can replace this Lambda function, the process Lambda function, with a state machine or AWS step function state machine, where you can create a workflow where you can, within the same application console, you can create a workflow. Maybe if you want, when a user object uploads a document with a PII, you may want to get rid of that PII. You can create that workflow and state machine within the same application composer console now, and then both your workflow and your infrastructure as a code in one and single console at the moment. Okay, you may ask me a question that, okay, what about if I have an architecture which is already created in my environment, for example? For that, I've basically picked up an application from an AWS samples page. Let me quickly show you. So I'm opening the project folder for that. So it is a command query response segregation pattern, right? So let me open the template. Okay, now you see that even if you have an existing architecture, it is visually showing you what the template is all about, how one resource is connected to another. And if you ask me, if anybody of the team asks you, okay, show me your latest architecture diagram for the code which is deployed in your architecture, you simply come here and export the canvas, share this image, and that's your design document right there within the console. Okay, if we switch back to the presentation mode, I want to take you through some of the resources. Let's go back to the presentation mode. Thank you. Okay, let's move ahead. Okay, these are some of the useful resources, whatever I have presented, or if you want to get started with this, serverless journey or application composer journey, you can leverage all the resources from the same page here. And you can also, for your serverless learning path, you can access this URL, s12d.com serverless learning, where you can find all the resources. And you can visit us. I'm here, obviously, if you have any more questions on this session or serverless, you can find me off stage here. And with that, I want to thank you for your time. please do take a moment to complete the session survey in AWS Events app. That's of immense value to us so that we can bring that content more and more to you. Thank you so much. Have a nice day.